In section 10.4, we're going to do measures of central tendency and variation. We're going to continue on with drawing a few graphs to finish up this chapter. And a lot of this material probably pretty familiar to you, but I do want to show you, sometimes people really enjoy doing lesson plans over this. I'm currently in the 7th grade standards, so it's definitely included in the 7th grade standards, but I wanted to go back to the 6th grade standards in case you want to use this for your lesson plan, and show you what some of these standards look like if I can get my internet to work. All right, here we go. So this is the 6th grade snapshot going into depth, and you can read through all of the standards. Remember, this semester we're doing lesson plans over geometric things, data analysis, probability type things. And what I want to show you is today we're going to be focusing on mean, median, mode, and range, which we call our measures of central tendency. We're also going to do some drawing of some box plots. And if you look here at the 612C, it says summarize numerical data with numerical summaries, including the mean and median, measures of center, and the range and the inner quartile range, which we'll do today. And use these summaries to describe the center, spread, and shape of the data. And then from that, we're also going to do some construction of box plots, which you can see in 613A. There will be standards over in yellow that support those. And just remember, if you do need to see or you would like to see the field guides over these standards, just shoot me an email and I will get the ones that you've specifically asked for to you. So let's go back and get our lesson done. Remember here you have some reading to do, 577 to 588. You have homework on my math lab, and then I've just given you on this video some extra problems from the textbook that you can work, but they're completely optional. We have two important aspects of data that we look at, the center and the spread. The center means describing where is the center of this data, and the spread is how far does it go out on each side from that center. The range and the inner quartile range and the standard deviation will talk about that spread, how far they are from the center of the data, and we're going to use mean and median to describe the center of the data. So you've probably already learned these. They used to be first introduced in 5th grade. That has now moved up to 6th grade, and in 6th grade is where we start doing that and drawing the box plots and things like that. But the measures of central tendency that we're going to look at are mean, median, and mode. Mean is the average, and you have an explanation and a formula there on your notes to describe that to you. Basically, it's as easy as adding up all of the data and dividing by how many, the number of data values there are. Rounding, if the mean is non-terminating decimal, round to one or more place than the original data. So if the original data is whole numbers, you're going to round to the 10th. If all of your data is to the 10th, then you're going to round to the 100th. You're going to go one more place than the original data. The median is the middle, so you have to definitely order those from least to greatest, and then find the value that's in the middle. If you have an odd number of values, then there's going to be a middle number. If there's an even number of values, you're going to have two middle numbers that you're going to have to average, basically add those two and divide by 2. The mode is the number that appears most often. There can be more than one mode. It can be bimodal or multimodal. You can read those definitions here to see what that means. But I do suggest that you read through examples 5, 6, and 7 on page 581. And look at 2A and B on 576, and there's going to be a discussion there as you look through that, and that's going to help you choose the most appropriate average. And so there are times that we use the mean because it's the most appropriate. There are times that we use the median because it's the most appropriate. There's times that we use the mode because it's the most appropriate. That's something that I want you to look at on your own because I think it's very easy for you to understand. And so if you'll go to your textbook and do that reading, that can definitely help you with that portion of it. All right, let's go to the next page of your notes where we'll work some examples. And so the first ones, we're just going to find the mean, the median, and the mode for the data here. And so have There it goes. Okay. So let me get back up to example 1. We're going to do the mean, median, and mode for this set of data. And so what I'm going to start with is I like to go ahead and order it from least to greatest. I just think that helps me remember that I have to do that for my median. And so my smallest number here is a 2, and then I have a 5, and then I have another 5, then I have a 7, an 8, another 8, and finally a 10. All right, so I'm going to calculate the mean, the median, and the mode for this set of data. If you choose to do this for your lesson plan, there are tons of excellent activities that you can find to do. I really like activities where students collect their own data, and then after they collect their data, they analyze their data, and there's a lot of activities that are already planned and prepared for you to use. You could definitely come up with one on your own. Depending on what grade you're looking at, a lot of these are going to be junior high lessons. You're going to try to find things that interest them, and so they can collect data from their classmates on things that interest them, and then they can examine it by calculating the mean, the median, and the mode of it. For this particular one, for the mean, what you're going to do is you're going to add up all these numbers. That's very simple addition. These all add up to 53. And then I'm going to divide 53 by 8 because there's 8 numbers in that set. When I divide that, I'm going to get the decimal 6 and then 625 thousandths. But since these are whole numbers, well, actually this one terminates, so we don't have to look at any rounding here. It's 625 thousandths. If it's a decimal that's non-terminating, meaning it goes on and on and on, that's when you're going to round to one more place. But since this one stops, we go ahead and write the entire decimal. All right, the median is the middle number. A lot of teachers will teach you to mark out your ends to examine which one is in the middle. And so when we do that, I can see here, because it's an even number, there's 8 of these numbers, that I'm going to have 2 middles. When I have 2 middles, I add them and divide by 2. So 7 plus 8 here is 15, divide by 2. That tells me that the middle is 7.5, 7 and 5/10, which makes sense because that's right between 7 and 8. The mode is the number that comes up the most, and in this case, that's obviously the 8. So that is example number 1, pretty straightforward. The next one, number 2, is actually, when we're in the younger grades, we just do a lot of averaging where we add up and divide by how many there are, and that's the grade. When you get into high school and college, we're looking more at a GPA. And so what you have to know is how many points each grade stands for. So we know that A's are worth 4 points. That's a 4.0. B's is 3 points, a 3.0, and then a C is 2 points. And so then you have to decide, well, how many credits was that worth? So if I'm going to do this GPA, I'm taking a history class, it's worth 3 credits, and I made a C in there. What I'll do is I'll do 3 times that 2.0. And then I'm going to add to it, well, I took math and I made an A, so that's 3 credits that I made a 4.0 on. And then I took a biology class, it was 4 credits, I made a B, so that's 4 times that 3.0. And then my PE class was worth 1 credit, 1 times the 4.0. But because I am calculating a GPA, it's basically like an average. What I have to do is I still have to do that division by how many credits there are. So when I add my credits, 3 and 3 is 6, plus 4 is 10, plus 1 is 11. So I do need to divide that by 11. All right, 3 times 2 is 6, plus 12, plus 12, plus 4. So I'm still adding and dividing by how many I have. When I add those up, 6, 12, 12, and 4, that's going to give me 34 divided by 11. And when I divide that, I get approximately 3 9/100 repeating. So that is my GPA for that semester. All right, so that's examples 1 and 2. Now we need to go back and look at examples 3 and 4. So let me get all this erased real quick. And let's see if I can just go on down. There we go. All right, so the next one, to receive a B in class, Ty needs to get at least a mean of 80 on 5 exams. His grades on the first 4 exams are 78, 92, 81, and 60. What is the minimum score that he needs to make on the 5th exam to make a B? So in this case, we're solving for an unknown. We don't know what he needs to make on that 5th exam to make a B. It does tell me that is the mean, it is the average, and so we are going to do the average calculation here. Once again, so I have a 78 and a 92 and an 81 and a 60, and I haven't taken that 5th test yet. It's the unknown, so I'm going to call it X. But I know when I add those up and divide by 5, I want to have greater than or equal to an average of 80. Basically, if you understand this formula, you're just solving for X, which is pretty easy. So what you're going to do is you're going to add up these numbers right here first. When you add those up, that gives us 311 plus that unknown grade. When it's all divided by 5, it needs to be greater than or equal to 80. I will then multiply by 5. So I have 311 plus X, which would be greater than or equal to 400. Subtract the 311. And so when I do that, 400 minus 311, that tells me that that grade has to be greater than or equal to an 89. I have to make at least an 89 on that 5th exam if I want to have an average of 80 for the class. All right, number 4. The mean for a set of 30 scores is 65. Suppose 2 more students take the test and score 95 and 100. What is the new mean? So again, we're still doing an average. When they averaged the first 30 tests, we had a 65. So what I need to add those other tests in is I need to know how many points those first 30 tests added up to. So I'm going to do 30 times 65 to get that those 30 tests, before it was divided by 30, added up to 1,950. Then I can add in those other 2 tests. So I have 1,950. I add the 95 and I add the 100. And now I'll divide that by 32 to get the average of the 32 tests now, or scores now, once those other 2 are added in. When I do that division, I'll take the 1950, the 95, and the 100, total that out. I divide that by 32. And what I do is I get a new mean of 67 and 300. So adding that 95 and 100 boosted that average up a couple of points. So pretty easy problems. Let's go ahead and go to the next page. And let me get back up to the top of this page. This thing is adding. Okay, here we go. All right, so this one, yours might say Miss Lacey, it might say Miss Holster, kind of the textbook changes, same problem though. So this one, we're not calculating a grade as easily, we're calculating it off of percents. So homework in this class is 10% of the final grade, group teaching is 10%, activities and quizzes are 10%, the average exam is the remainder of the grade. If you made a 92 on the teaching presentation, a 94 on the homework, an 87 on the activity and quizzes, 72 on exam 1, 85 on exam 2, 80 on exam 3, 91 on exam 4, and 68 on the final exam, what would your numerical grade be for the class? And you might want to pause the video and kind of read through all of that again. It's kind of a lot of information. But this is how we calculate a grade when it's based off of percents. And so first thing I look at is 10% of my grade is homework. And so we know to do a calculation with percents, we have to change that to a decimal. And so 10% of my grade is homework. What was my homework average? Well, that was a 94. So I have to do 10% times a 94. Plus, the next part of my grade was the group teaching presentation. That was 10% as well. And what did I make on that? So a 92 on the group teaching presentation. All right, next thing is 10% is my activities and quiz average. So plus 10% times, what did I make on that? That's an 87. Plus, the rest of the grade is my test average, my exam average. So I have 10%, 10%, 10%. So 30% of my grade is counted for. So what I'm looking at now is the remaining 70%. Okay, so the remaining part of my grade is the exam average. So I have to average the exam. So I'm going to have to go off to the side and do that. So I made a 72 on exam 1, then I made an 85, then I made an 80. I'm going to have to go down here. Then I made a 91, and then I made a 68. And I need to add those 5 tests up and then divide that by 5. All right, so 72, 85, and 80, 91, and 68 on the 5 tests. Total those up, divide by 5, and when I do that, I get an average there of 79 and 2/10. That went right there. All right, so now it's as easy as using a calculator. We're going to do 10% times 94, 10% times 92, 10% times 87, and 70% times the 79 and 2/10. I'm going to add all that up. When I add all of that up, I get that my grade is 82 and 74 hundredths. So that's how you calculate a grade based off of percents. On number 6, it says, suppose in Joy's class there were 5 students who scored 75 and 10 students who scored 95. What is the mean or the average of the scores in the class? Well, this one's pretty easy. I have 5 students who made a 75, so I got to do 5 times 75, plus the other 10 made a 95, so I've got to do 10 times the 95. And what that's going to do is that's going to add up all of the tests for the 15 students. Then I'm going to take that and I'll divide it by 15. So that's 1,325 divided by 15. This one, if you divide it, we have that non-terminating decimal, the decimal that keeps going. And so since these are whole numbers, we'll round that to the nearest tenth, and that's going to make my average 88 and 3 repeating tenths. All right, number 7 is pretty interesting. And then we'll go into measures of variation. So 8 students scored 60 on a test. So we have all 8 students made a 60. If you need to, you can write this out. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 students who scored a 60, and we need the mean, the median, and the mode. Well, I hope that you wouldn't have to do any calculations. If you did, that's fine. But you should know that if you have 8 students who made a 60, if you add all of that up, that's going to be 60 times 8, which is 480, divided by the 8, which would be 60. And you really don't even have to do that. You should know if every student made a 60, then the average of their grades would be a 60. The middle number would obviously be a 60, and the one that comes up the most would be a 60. So if you can see that without writing anything down, that's perfectly fine with me. I like part D because it asks you to make up another set where you come up with a different set of grades for 8 students who also have a mean, a median, and mode of 60. There are different ones that you can come up with. The one that I came up that works is one student made a 30, one made a 40, one made a 50. We had, oh, my pen's going crazy, a 60, another 60, a 70, an 80, and a 90. The reason this one works is because if you add all these up, it all also adds up to the 480, and if you divide that by 8, you get that average of 60 again. The middle number is obviously 60, because if you add the two 60s and divide by 2, you get 60. And the one that comes up the most is also 60. This is not the only one that works, but it definitely is one that works. This is a really good problem to give to your students because they have to come up with that data set on their own. So all of those problems that we've done so far describe the center of the data, the average of the data, the middle of the data, the most of the data. What we're going to look at next is variation. How far does that data spread out from the center? And we look at range, variance, and we don't really talk much about standard deviation at all in this class. We're going to look more at range and variance. Range measures the spread. It says, okay, how far is it from the highest number to the smallest number? Something that students have a very easy time with. The way that you do that is you take the maximum number in the set and you subtract the smallest number in the set. So for example, super easy problem. On this one, it would be very easy to find the mean, the median, and the mode. But then the range describes how far does that data spread from its smallest number to its biggest number. Well, its biggest number is 10, its smallest number is 2, so there is a spread of 8 from the smallest to the biggest number. And so that helps us describe our data. All right, let's go ahead and go on to the 5th page. Always get some lesson plans over box plots. If you look in your textbooks, you're going to get some really good examples from that, from page 583 to 588. This is something that, you're going to want to learn these steps. The 5-number summary, this is going to be on your test. I would probably put this on a note card if I were you. This is how you do a box plot, how you build it, but it's based off the 5-number summary. And so there's going to be 5 numbers that you're going to calculate. You need the least value, the minimum, Q1, which is the middle of the lower half, Q2, which is the middle of the whole set, Q3, which is the middle of the upper half, and then number 5 is the maximum number. But then you have to test to see if you have any outliers, because there's a lot of times where your minimum or your maximum could be an outlier, and if they're an outlier, that's a number that is widely separated from the data. If it is an outlier, you kind of throw it out, your box plot, and it's just described with an asterisk showing that it's an outlier, showing that it's farther away from the data. The way that you calculate outliers is you do a little test with the IQR, which I'll show you how to do, but this is all much easier to do when you're actually doing an example. So I'm going to scroll down. You're going to want to look up at these 5 steps as we do this problem, and it'll be easy to understand when we do an example. Okay, so on number 1, when you're doing this, first thing you have to do is absolutely make sure your numbers are in order, because we're doing a lot of medians, and when you're doing medians, your numbers have to be in order. So I checked number 1. It looks like it's in order, and so I'm going to do my 5-number summary. Number 1 is the min. Number 2 is my Q1, which is the middle of the lower half. Number 3 is Q2, which is the median of the whole set. Number 4 is Q3, which is the middle of the upper half. And number 5 is our max number. So when I look at this, my minimum number is 7. That's the smallest number in the data. And I'm going to count my numbers. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 total numbers, which means I will have 1 median. I can cross off the ends, but it's pretty easy to see on this one that 15 is the middle number of the whole set, and that is the Q2. And then the maximum here is 35. I always do those 3 first and then go back and do Q1 and Q3. When you have one middle number like we have here, that is not included in the lower or the upper quartile. So these numbers are the lower up quartile, and then the other side is the upper quartile. So I'll just make you a note. This is the lower, this is the upper. that 15 is not included in either one. That happens when there's one middle number. And I'll show you an example in a minute where there's two middle numbers. All right, so what I need now is Q1. If you look up at the top, it's the median of the lower half, the middle of the lower half. So when I look here, there's two middles. When there's two middles, I add them and divide by 2. So when I add them, that's 21 divided by 2, which is 10.5. Here I have two middle numbers. That's my Q3, the middle of the upper half. And so when I look at that, you can add and divide by 2 if you need to, but you should know, since it's the same number, that that number is going to be 18. So that's your 5-number summary, but we don't know. Some of those numbers could be outliers, which is what we have to check for in number 2 before we actually draw the box plot. And so if you need to go through that again, just kind of rewind the video and go back through how you got those. But after you do it a couple of times, I think it'll be pretty easy for you. What we need next is the IQR, the interquartile range. And we're going to use that to test for outliers and see if there's a number that's pretty far off the data, pretty far away from the center. The way you do the IQR, you can look above on your notes. That is Q3 minus Q1. So that's 18 minus 10.5, which is 7.5. And we can use that IQR to test for outliers, which is also above in your notes. So we're looking for numbers that are widely separated from the center. What we do is we test, do we have any numbers below Q1 minus 1.5 times the IQR? And we can go ahead and do that. That's really easy. Q1 is 10.5. Then we have minus 1.5 times the IQR, which is 7.5. And when we do that, 10.5 minus 1.5 times 7.5, that's going to equal negative 7,500. So we're looking, do we have any number in our set that's below that? And we don't. Our smallest number is 7. That's definitely not below negative 7,500. So the bottom end of the data is fine. Now we need to look at the upper end of the data. Do we have any number above Q3 plus 1.5 times the IQR? So we have Q3 is 18 plus 1.5 times the 7.5. And when we calculate all that out, that's going to total for us 29 and 2,500ths. Do I have any numbers above that? Yes, I do. 35 is above that. So I come up here. This number 35 right here is an outlier. If it's an outlier, it can't be the max of my data. So I remove that 35 because it's an outlier. And now my max is this next number here, which is the 20. All right, so again, none of that's hard. It might be new to you, so if you need to rewind the video and stop that, do so. And then we're even going to do another example, and I think you'll be perfectly fine after that. So let's go to the last page of the notes. And what we're going to do on that last page is we're going to take all of that information and actually construct our box plot. So when you do box plot, basically you're going to start by drawing a number line. And I'm going to leave it up to you as far as what you want to go by. So the smallest number in this data is 7. The largest number is 35, but that's an outlier, but we still have to mark that. So what I chose to do is I chose to go by 5s here. So we would have 0 starts this. We have 5, 10, and so forth. And I'm going to go ahead and just stop at 40. Those arrows show you that the number line continues to go on in both directions, but we don't need anything past 40 for sure. And so what you're going to do is you're going to plot your 5-point summary. So my minimum, you're just going to plot it a bit above, is, and I'm going to change this to red so it's really easy to see. My minimum number was 7. And then my Q1, go back and look. My Q1 was 10.5, so that's going to be right here. Then I had my Q2 was the 15. My Q3 was 18. My maximum was 20. And then the 35 out here, we're going to use an asterisk to denote that. That's an outlier. And so we have 7, 10 and a half, 15, 18, and 20. So we have all those numbers correct. What you do is you draw a line in from your min and your max to your Q1 and your Q3. And then here you create the box around Q1 and Q3 and down a line through Q2. And what this does, it kind of describes where your data is heavy. You can see 35 is an outlier. You can see 15 is the middle. There's actually more numbers, or when you look at, there's a wider spread on the lower quartile getting you down to 7, and that's describing that. There's not as much spread getting you up to 20 on the other side of the graph. And so a box plot kind of describes where your data starts, if there's an outlier, and where, where there's more of a spread, below the middle or above the middle. So that's how you do a box plot. I've given you another one to practice. If you want to stop the video and try this one on your own, that's a really good idea. If you don't feel comfortable enough to do that, you can just leave the video on and I'm going to go through this whole problem with you. So remember, first thing, these numbers not in order in this one. So you definitely have to put them in order. So I have 20 first, then I have 40, 70, 70, 80, 80, 90, 90, 95, 95. All right, so there's all my numbers in order. And then I'm going to do my 5-number summary. So I have my max, my median, my min, which is Q3 or Q2, excuse me. Q1 and Q3. So my min is obviously 20. My max is obviously 95. All right, when I look to the middle, I can count in. I have 2 middles in this case. When you have 2 middles, you add and divide by 2, but that one's pretty straightforward. That's 80. And this is where there's a difference from the first example. When there's one middle number, you don't include that in the lower and upper quartile. When there's 2 middles, they are included in the lower and upper quartile. So here is my lower on the left side, my upper is on the right side. And so from here to here is my lower, from here to here is my upper. So when there's 2 middles, you include those in the lower and upper. And then Q1 is the middle of the lower, which is 70. And then Q3 is the middle of the upper, which is 90. And so those are the numbers that we'll use for our box plot unless any of those are outliers. So we'll go ahead and we'll test for outliers. I need to calculate the IQR, which remember is Q3 minus Q1. So that's 90 minus 70, which is 20. And I'll use that to test for outliers by using the formula. Do I have anything below Q1 minus 1.5 times the IQR? So this is going to be 70 minus 1.5 times 20. When I do that, I get 40. So do I have anything below 40? Yes, I do. 20 right here is an outlier. If it's an outlier, it can't be my minimum. So now my minimum has to be 40, and 20 is just an outlier. Okay, I got to check the upper side of the data. So do I have anything above Q3 plus 1.5 times the IQR? So Q3 is 90 plus 1.5 times 20. So that's going to give me 120. Do I have anything above 120? No, I do not. So These now are the 5 numbers that I'm going to use on my box plot, and 20 is an outlier. So let me get a clean page to do this. And so you're going to draw your number line. Here my numbers go higher than the last example, so I'm going to go by tens. And I'm going to stop at 100 because I don't have any numbers larger than that. All right, so at 20, I have an outlier. My minimum is at 40. Q1 is at 70. Q2 is at 80. Q3 is at 90. And then my max is 95. So remember, you go from your min to Q1, your max to Q3, a box around Q1 and 2 with the line down the middle. And when you see this, you can see 20 is definitely an outlier. The middle is 80. 20 is very far from 20, so it makes sense that it's an outlier. There's more of a spread from the middle to the lowest number. And there's not as much of a spread from the 80 to the 95, and so you can see that in the box plot. So this is section 10.4. This finishes up our first unit, so you should be able to complete your homework. As always, if you have any questions at all, just feel free to email me at any time, and I'd be happy to help you. Again, if you need more instruction, go online to the multimedia library, and you can do the PowerPoint as well as the video lectures from there to go through more things with you if you feel like this is not enough. Also, the textbook readings can help you a lot as well.